The latest fad in the science denial movement is to claim that space is fake because a gaseous atmosphere cannot exist right next to the vacuum of space. This isn't all that new, but recently the denial crowd has cherry-picked an MIT lecture about ideal gases, and they've crafted a story about the second law of thermodynamics. I've got to hand it to them, they really have the debunking crowd triggered, myself included. Plenty of others have already addressed this story, and I have nothing to add to that. Instead, I want to try something a little different. I just want to ask some questions.
Why don't you just answer the question?
Be honest, no big deal.
Yeah, answer it.
Just answer the question, Claire. Talk to us.
Come on,
Answer the question. Don't be a
it's
jerk.
easy.
If we all stop trying to prove our points, maybe we could try listening to each other for just a moment. I'm happy to go first. I honestly do not understand the logic behind this vacuum argument. I've got questions, and if you're willing to talk to me, I'm here to listen. So if anyone out there believes in this idea that an atmosphere cannot exist next to the vacuum of space, please consider answering these simple questions. Make a video or just leave your answers in the comments. And all the globulists out there, I already know your answers. I'm happy to hear your ideas as well, but let's give the other side a chance to speak first. First, some simple questions about atmospheric pressure. These are merely intended to establish a baseline. I expect the answers to these questions will show us where we agree and where our ideas start to diverge. So question number 1. What is standard atmospheric pressure? Choose whatever units you like, but I'm asking for a number here. See, I told you these were going to be easy. Question number 2. What would the pressure be in the vacuum of space? And number 3. Does atmospheric pressure change as you go up in altitude? Does pressure increase, decrease, or stay the same? Number 4. What is the atmospheric pressure on the top of Mount Everest? Question number 5. What is the pressure at the altitude a jet airliner flies? And question number 6. What is the lowest pressure we can get within our atmosphere? Or what is the lowest pressure you'd be willing to believe is possible within our atmosphere? If you're still with me and you've been compiling your answers, thanks. Next, I'd like to shift gears a little and explore how pressure and forces work in an imaginary experiment. If you're willing to do a little math, consider a box with a 1 square inch hole in one wall. Bonus question. If a circle has an area of 1 square inch, what is that circle's diameter? So take a box with 1 square inch hole. Into that hole, we'll put a plunger and seal around it. We'll put a spring scale on the end of the plunger so that it measures how much air pressure inside the box is pushing against the plunger. Before you seal the box up, we'll zero out the scale so that it's measuring 0. Now attach an air pump to the box and seal it up. Next, put that box inside another box. This outer box will have an air pump on it too, and we'll seal that one up too. We have a box within a box with 2 air pumps so we can control the pressure in each container separately. We'll use the plunger with the scale to measure how much force the different air pressures are causing. Exercise number 1. Fill both boxes with standard atmospheric pressure. That was your answer from question number 1. So now, how much force do we measure at the plunger right here? Let's do the airplane action movie thing. Leave the inner box at standard atmospheric pressure. That's where the passengers are going to sit. Pump down the outer box to whatever the pressure should be outside our aircraft. That was your answer from question number 5. So now, how much force does the plunger show? You know we've got to do the sci-fi version of this. Matt Damon is going Iron Man. Exercise number 3. Pump the outer box down to the vacuum of outer space. That's your answer from question 2. Leave the inner box at atmospheric pressure. That's supposed to be the inside of Matt Damon's spacesuit. How much force does the plunger show? How hard does that 1 square inch hole push as he rockets through space like Iron Man? So there you go. That's 10 total questions, if you count the bonus one. They're not supposed to be gotchas or anything. I just want to compare your answers to my own to see where our thinking is the same and where it's different. I haven't given my answers to these here, at least not yet. I plan to give it a few weeks to see if anyone is willing to respond, and then I'll give my own answers for comparison. After that, let's talk about what all this means to each of us. Looking forward to your responses.